Hey everybody, in today's lesson we're going to be looking at similarity of figures. So this is going to be the first lesson of the unit and we're going to start out by talking about scale diagrams. Now I have some of the notes filled in for you, so please pause the video if you need to record down all the important information. Now we'll start off with looking at representing ratios. A scale diagram is a reproduction of a diagram that can be larger, smaller, or the same size as the original. Each dimension is multiplied by a number called the scale factor. So what we're going to look at today is either using that scale factor or calculating that scale factor. In any scale diagram, a ratio is given to identify the factor used to enlarge or reduce the actual object. Now, it can be written as this setup right here, so your first part colon and then your second part, or it can be written as a fraction. So either one is correct when you're looking at writing a ratio for this scale factor. Now, the A would be the scale. So the top part is always going to be your scale, and the bottom is going to be your original. So what the actual measurement is. So it's important to keep it this way always, that your scale is on top and your original is on the bottom, so that we make sure that when we set up the calculations, we're doing them consistently the same. So we're not mixing them up or switching them around, because that's going to lead to difficulty with understanding the proper ways to calculate it. So it's always important that we're looking at having the top part as our scale and the bottom as our original. Now, in this first one here, we look at 1 colon 1. So this is a full scale. Now, a full scale, so 1 over 1, which is equal to 1, is a drawing that is made to the actual size. So whatever you're drawing is an exact replica of what you wanted to draw, so the actual object. And you're keeping it to the exact same dimensions as that object or picture would be. When we're looking at 1 to 4, so the first number is smaller than the second number, you're looking at reducing the scale. So if we wrote it as a fraction, we'd have 1 over 4. So this means the drawing is smaller, and if we have 3 colon 1, it's going to enlarge the object. So when you're enlarging something, you're making it bigger. Now, an easy way to remember this is if the number on top is smaller than the number on the bottom, it is going to reduce the size, so it's going to get smaller. If the number on top is bigger than the bottom, it is going to enlarge that object. Let's take a look at this and see how it plays out when we do the first example. In this first one, we have a scale of 1 millimeter equals 25 meters. What actual distance is represented by the following scale diagram? Now remember above, there's two ways of writing this scale factor. We could write it as 1 colon 1, 25, or we could write it as 1 over 25. When we're looking at doing our calculations, we're always going to use the fraction. So in this first one here, we have 1 millimeter equals 25 meters. So we have 1 on top and 25 on the bottom. So we have our millimeters on top and our meters on the bottom. And meters is what the actual measurement is, and millimeters is our scale drawing. So we have our scale on top and our original on the bottom. Now we're going to put this beside our 9 millimeters, which is what we have, and we want to figure out what 9 millimeters would be on the original object. So we'd have an X here. Now we've set up our cross multiplication so that we're going to cross multiply the 25 and the 9 and the x and the 1. This will get us 1x equals 25 multiplied by 9. Well, 25 multiplied by 9 equals 225. And important that we write down our unit. So we're looking at the original, which was in meters. So our final unit is going to be in meters. And this would be our final answer. So 9 millimeters equals 225 meters on the original object. Now we have 60 millimeters. We're going to use the same scale factor. So we have the 1 over 25 equals, we have our 60 millimeters of the drawing. So the 60 goes on top because we have millimeters on top and meters on the bottom. And we have our x here. We're doing our cross multiplication. So we're going to end up with 1x equals 25 multiplied by 60. Well, 1x, so just x is the same thing, equals 25 multiplied by 60, which is 1,500. And important that we include our unit of meters at the end. So when we're looking at scale factor and calculating for scale factor, we're always going to be using this cross multiplication method. And it's important that we have our scale on top and our original on the bottom. And if we stay consistent with this, we can always follow the same rules when calculating. Now, if no unit of linear measures are given for the scale, example 1 to 5, then its measure of the units of linear measurement must be the same. So that's saying that if there's no unit included, then we're assuming that the unit is going to be the same as what you started with. So this one here, we have no unit given. So we have 12 to 1. The scale is 12 to 1. What actual distance is represented by the following scale dimension? So they're giving you the scale dimension, so 24, and we want to figure out what the actual is. So that's going to be your original. And if we follow that we have scale on top, and original on the bottom, we can calculate for this. So we want to use our 12 over 1 equals, and we have our scale of 24 over, we want to find out what the original would be, so we put an x here. Now we do our cross multiplication. We get 12 x equals 24 times 1, so 1 times 24. Now we have to get x by itself, so that means that we have to divide by 12 and divide by 12. This cancels off, so what we're getting now is 24 divided by 12. Let's just make this a little bit clearer so you can see it. So we have x equals 24 divided by 12. 24 divided by 12 gives us 2. And our unit is going to be meters. So that would be our final answer. Now we have the same scale for B, which is going to be 12 over 1 is equal to, and we have 144 over x. We want to do our cross multiplication. And this is going to give us 12x equals 1 times 144. Now divided by 12, cancels off on that side. So we get x equals 144 divided by 12. And 144 divided by 12 equals 12. and our unit is the same, so we have 12 meters. So that's the actual measurement based off of using the scale of 12:1. For B, we're going to look at using a scale of 1 to 50. What would the scale length of a 6,000 millimeter line be? Remember, we have scale on top, so we're trying to find out what would the scale length be. Our ratio is 1 to 50 equals, we want to find our scale, meaning our x goes on top and our 6,000 goes on the bottom. We've got our cross multiplication set up. This is going to come up, this is going to come up, and multiply, which gives us 1 multiplied by 6,000 is equal to 50 multiplied by x. Take this further, we have 6,000 equals 50x. We need to get x by itself, so divide by 50 and divide by 50, canceling it off. So we get 6,000 divided by 50, so x is going to equal 120, and our unit that we looked at here was millimeters. So 120 millimeters. Let's slide down to example 3 here. We have a scale diagram has a length of 20 centimeters. If the scale is 1 to 100, what is the actual size? So we have a scale of 1 over 100. And we have a scale diagram, meaning our scale is always on top, so we have 20, and we want to find out what the length of our actual diagram would be. So we have our x on the bottom, because that's where our original goes. We set up our cross multiplication. So we have 1x equals 100 multiplied by 20. Now if we take this further, we have x equals 100 multiplied by, gives us an answer of 2,000, and our unit is going to be centimeters. And that'll be our final answer. For B, it says if the actual length of the table is 2.5 meters, so that's your original length, and the scale is 1 to 50, what is the length of this drawing? So we'd have 1 over 50 equals, we have the actual length, so our scale is on top, and our actual length is 2.5. So we've set it up now so that we can do our cross multiplication, which gives us 50x equals 1 times 2.5. Take this further, we end up with dividing by 50, dividing by 50. So we have x equals 2.5 divided by 50, and we get x equaling 0.05, and our unit of measure was meters. So that would be our final answer. For C, it says, what is the scale if the length of the bookshelf in the drawing is 1.25 centimeters and the actual length is 2.5 meters? So we want to figure out what the scale is in the length or if the length of the bookshelf is drawn to this. That we determine this is we have our drawing over our original. So we have the size of our drawing over our original, which equals 1.25, and we have centimeters over our original, which is 2.5 meters. Now, when we have it like this, we want to try and reduce our fraction. Well, 1.25 goes into 2.5 twice. So Dividing 1.25 by 1.25, you get 1, and dividing 2.5 by 1.25, you get 2. So our fraction now is 1 over 2, and we have centimeters over meters. It could also be written like 1 colon 2, and you'd include your centimeters and your meters. So that's how we would write out what our scale factor is. So either one of these would be your correct answer. Now, for example 4 here, using a scale of 1 centimeter equals 3 meters, draw the line to represent the following actual lengths. So we have the following actual lengths below. So that means this number, so 30, is an actual length, and we want to find out what the scale would be. Using the scale of 1 centimeter over 3 meters, we want to find out what our scale is, so x goes on top, and our 30 meters goes on the bottom. Notice how the meters and meters are beside each other, and we have our centimeters, and we're going to find our scale, which is going to be in centimeters. So we cross multiply, and we're going to have now 1 times 30 equals 3x. We want to get x by itself, so we divide by 3 and divide by 3. Cancels off there. We're going to get x equaling 30 divided by 3, which is 10, and our unit is centimeters. For 18, we follow the same scale of 1 over 3 equals x over 18, and we cross multiply, giving us 3x equals 18 divided by 3 cancels off there. We get x equaling 18 divided by 3, which would be 6 centimeters. Now we got our last example for the day, which is example 5. Using the scale of 1 millimeter equals 25 centimeters, draw a 600 by 800 rectangle. So we want to figure out what those measurements are going to be when we're looking at using a scale of 1 millimeter equals 25 centimeters. So we have 1 over 25 equals, and it's asking us to draw it, so that means we're trying to find the scale. So they're saying the original was 600 by 800, and we want to find the scale, so x goes on top, and we just use one of the dimensions right now, so let's use 600 first, and we do our cross multiplication, so we get 25x equals 600 divided by 25, cancels off, divided by 25, gives us x equals 600 divided by 25, which is 24, and that's going to be millimeters. And we could also convert this into centimeters, which is going to be 2.4 centimeters. Now we can do our other dimension, so 1 over 25 equals x over 800 is our other dimension that we're working with. So we do our cross multiplication, and we have 25x equals 800 divided by 25 divided by 25. Cancels off on the left hand side, so we have 800 divided by 25, x equals 32 millimeters, and if we wanted it in centimeters, it would be 3.2 centimeters. And these would be our dimensions for converting our dimensions of 600 centimeters by 800 centimeters using the scale factor of 1 millimeter equals 25 centimeters. Now that'll finish off the lesson for today. Remember, the most important part about this is that when you're setting up your scale factor to do cross multiplication, you have your scale on top and your original on the bottom. Other than that, if you have any questions, you can send me a message over Teams or ask me in class. Have a good day.